So we're into 8.1 now, and what we're trying to do is determine what these functions are doing, whether they're increasing or decreasing. I made a sketch somewhere. All right, don't make fun of it, please. It's not Picasso or anything. But obviously this is decreasing, this is increasing, and if we have a cubic, which this is supposed to be symmetrical, but it's decreasing at this point. These are, and it's increasing here, and these are called critical points. So that's what we start out finding. We start out finding the critical points, and then we go from there. And this is the only time when it gets tricky. Actually, it's all kind of tricky, but anyway, we've got to find the critical points of the derivative. So first we're going to find the derivative. Then pause it. Okay, after we find the critical points, we've got to, what we're trying to do, let's go back to this one, is determine what the behavior of y as x increases. The behavior of y as x increases. So we find the critical points, and then we find a value above x, above the critical points on the x-axis, and then we put it into the equation, and then we solve it. And this probably makes no sense right now, but if the function is less than 0, then, if the derivative is less than 0, then it's a decreasing function. If it's greater than 0, then it's an increasing function. Okay. After we do this, then we adjust the inequality accordingly. Now this is kind of the hard part, is knowing to do that. So keep that in mind. It's not always going to be what the inequality suggests after you solve the problem. So you might have to adjust it. And that's why we test it. That's why I use that word. Okay. Okay, so let's come back to this. So we're going to find out the range of values of x for which this is increasing. Find the range of values, and that's the same equation. That's a cubic, is decreasing. That's what we're going to do. Okay, so for me, this is the easiest way to go about it. So we're trying to determine whether it's increasing. Remember the function, if it's increasing, it's going to be greater than 0. So now we're going to factor and solve for x. So we found our critical points, and the critical points are our maximum and minimum. So if I put, for instance, 5 into the equation, we're going to get 0. Multiply it all out, it's going to be 0. If I put -1 in, we get 0 here. Multiply it all out, the whole thing's 0. But let's go back to this one. We're trying to determine what y is doing as x increases. So what we're going to do is we're going to pick some numbers a little bigger on the y-axis, on the x-axis that are convenient to use. How about if we use 6 for this one, and we're going to use 0 for that one? Why not? And what we're doing is we're testing. So this is why I said test. So we're testing. And if it doesn't work, then we're going to change the inequality. So here we go, we're at this step now, and what we're doing is we're testing it. So for x is greater than 5, I just picked a value bigger than 5. 6 is bigger than 5 last time I checked. And what we're going to do is we're going to put 6 in to this equation. 6 minus 5 is 1, 6 plus 1 is 7. That's obviously bigger than, 7's bigger than 0, so that means this one's right. So this one passed the test. Good job, x is greater than 5, you passed. Okay, let's look at this one. So we've got -1, -1. Oh, anyway, I chose 0 because 0 is bigger than -1. So -5, 0 minus 5 is -5, 0 plus 1. So we get a negative here. Sorry, you failed, x is greater than -1. So what I'm going to do is I'm going to adjust this inequality accordingly. So I'm going to flip it. So that means I get x is less than -1, x is greater than 5. And I'm going to show you the behavior of this cubic on Desmos in a moment. Now here's the easy part. For part B, we just switch the signs. Okay, so this is going to exist in this range, and I'm going to show you on Desmos right now. Okay, we're going to look at where it's decreasing first. It's between -1 and 5. And here we're at -1, 28. This isn't the easiest graph to work with. Okay, and 5, and 5 is another turning point. So between -1 and 5, it's decreasing. Okay, and let's go back to part A. Go to part A. Greater than 5, less than -1. Greater than 5. Okay, and it's going to be less than -1. We have that covered here at 5. Now I've got to scroll all the way to -1 to show you. Hang on. All right, there it is, less than -1. So if you go all the way through infinity from the negative direction up to -1, it's increasing.